The Science of Meditation. Chapter 12. The Science of Meditation. When I first began compiling my articles on meditation into a book, I decided to name it The Essence of Meditation. That was because the main purpose of this book is to discuss the biological essence of meditation, which is exactly what I am attempting to uncover here. However, when I shared the initial draft of the book with some readers, I received a response from Dr. Stephen Sloman, a psychology professor at Brown University, who said, "I enjoyed your book. It's a very interesting perspective on meditation. It feels nicely scientific and concrete. However, I don't like the title of the book because I'm not much of a believer in essences. Since most of the claims you make in the book are hypotheses and theories, rather than facts, why not call your book The Science of Meditation?" I believe that most readers would find themselves somewhat puzzled by this comment. If I acknowledge that most claims in the book are hypotheses and theories, rather than facts, then the original title, The Essence of Meditation, does indeed seem somewhat inappropriate. But even if I were to consider a title change, would a new title such as The Hypotheses of Meditation or The Theories of Meditation be more appropriate than The Science of Meditation? That is because, for most people, science is synonymous with facts and truth. In everyday life, we often hear people say, "That's not scientific," by which they mean that something is incorrect. However, that might actually be one of our biggest misunderstandings about science. Karl Popper, hailed as one of the greatest philosophers of the 20th century, argued that scientific theories or propositions cannot be proven true, but can only be falsified. He further pointed out that only theories or propositions that can be falsified are scientific, while those that cannot be falsified are non-scientific. In other words, the criterion for distinguishing between science and non-science is falsifiability. One classic example of Popper's argument is the white swan hypothesis. Before the discovery of black swans, although people had only seen white swans, they could not confirm the hypothesis that all swans are white. However, that did not prevent that proposition from being a scientific hypothesis, because the discovery of a swan of any different color would easily falsify that hypothesis. Of course, after the discovery of black swans, one could propose a new hypothesis that all swans are either white or black. Similarly, until swans of colors other than white and black are found, that new hypothesis would be scientific. However, statements like, "There are golden swans in the world," are considered non-scientific because they can never be proved wrong, that is, falsified. Popper's theory can indeed help us to effectively distinguish between science and non-science. It also offers an important insight: science does not equal truth. In other words, something being scientific does not guarantee its correctness, and conversely, something being non-scientific does not necessarily guarantee its incorrectness. For example, if someone dreams of golden swans and firmly believes that there must be golden swans in the world, that does not necessarily make that person wrong, but the belief is non-scientific. As a matter of fact, many human activities are non-scientific, such as religion, art, and philosophy. While those activities cannot be falsified, the way scientific hypotheses can, they also cannot be labeled as wrong. For instance, people would not say that Leonardo da Vinci's Mona Lisa is wrong just because it's a work of art and not a scientific fact. To determine whether the hypotheses and theories presented in this book are scientific or non-scientific, let's apply Popper's criterion to them. The first, most important, and boldest hypothesis that I propose in this book is that the biological nature of meditation keeps the mind awake, while letting the body fall asleep. In other words, meditation is sleep. It is awake sleep. It is sleeping with consciousness. To confirm that meditation is sleep, we would need to measure all known physical variables in the body, such as heart rate, and all known chemical variables in the body, such as hormone secretion levels, and compare their changes during meditation and sleep to see if they align. Even if one could find that all these known variables have matching values in meditation and sleep, one still could not conclusively state that meditation is the same as sleep. That is because the human body is a super-complex system with an enormous number of physical and chemical variables, with new variables constantly emerging as science progresses. In other words, one can never be certain that one has comprehensively identified and validated all physiological variables in the human body. If it is impossible to prove that meditation is sleep, it is relatively easy to falsify that hypothesis. If any physical or chemical variable in the body behaves differently during meditation than during sleep, one can conclude that meditation is not the same as sleep. For example, as mentioned in the previous chapter, human hibernation, while both meditation and sleep can lower heart rate and slow breathing, the heart rate and breathing rate during extremely deep meditation can become even lower than during regular sleep. Thus, merely based on the differences in these two variables, one can easily refute the hypothesis that meditation is the same as sleep. That is precisely why, in the previous chapter, I redefined the biological nature of meditation as keeping the mind awake while allowing the body to fall asleep, or even enter a hibernation-like state. Another case even closer to hibernation occurred in October 2006 when a 35-year-old Japanese man named Mitsutaka Uchikoshi was found in the wilderness after being in a coma for 24 days on the cold ground, with his body temperature dropping to 22 degrees Celsius, or 72 degrees Fahrenheit, and both his pulse and breathing having ceased. However, he astonishingly regained consciousness after being transported to the hospital, and no brain damage was detected after his recovery. While these cases cannot prove that human beings possess the ability to hibernate, they do suggest that humans might have this potential. Some scientists even believe that all mammals may have this potential because mammals evolved from reptilian ancestors, and the vast majority of reptiles are cold-blooded animals that must hibernate to survive in colder regions. However, most mammals have gradually forgotten this ability over the course of long evolutionary periods. Indeed, humans can be induced into a state similar to hibernation through a technique known as therapeutic hypothermia, or targeted temperature management. This technique has critical applications in treating medical emergencies such as cardiac arrest and brain injury. Cardiac arrest, which occurs when the heart suddenly stops beating, has a high mortality rate. Even if the person survives, just a few minutes of severe brain ischemia, lack of blood flow, usually leads to irreversible brain damage. However, by promptly inducing patients into an artificial hibernation-like state, it is possible to slow down the injury and buy time for further treatment. Clinical practice has demonstrated that this method can increase the survival rate of emergency patients and reduce the risk of neurological damage. In 2013, this technique was even applied to treat the brain injury of the renowned Formula One driver Michael Schumacher. The technology of inducing artificial hibernation not only has life-saving potential, but also could shape and extend the future of humanity. In many science fiction books and films, astronauts are placed in hibernation to prolong their lifespan during years-long interstellar journeys, which reduces resource consumption and spacecraft load, and, more importantly, allows the astronauts to arrive at their destination at a still relatively young age. Currently, the National Aeronautics and Space Administration, NASA, and the European Space Agency, ESA, are both researching space-applicable hibernation techniques for crewed missions to Mars and future interstellar colonization. However, this form of human hibernation is still in the experimental stages and has not gained universal acceptance in the scientific community. Many scientists believe that it contradicts the laws of physics, chemistry, and biology. Moreover, many countries either prohibit or restrict the use of human cryonics, and even where it is allowed, it is typically limited to bodies that have been declared medically dead. While we can understand that people facing terminal illnesses might view cryonics as a last-ditch effort to extend life, there are still many challenges associated with this technology. For instance, the high-concentration cryoprotectants used in tissue preservation can poison cells, despite preserving tissue integrity. Also, there are potential risks and unknowns associated with the thawing process in cryonics, and the reconstruction of the human body is a monumental undertaking that would require nanomedical technologies operating at the molecular level. Moreover, the fundamental question remains whether memory and consciousness can be repaired solely by restoring neural structures. Even if a neural structure is well preserved, it remains a mystery whether memory and consciousness can be restored solely by neural reconstruction. Therefore, while cryonics is an intriguing concept, it still faces significant scientific and practical challenges. So, is there a safer and more reliable way to induce a hibernation-like state in humans? The answer is yes, and that method is meditation. In meditation, you maintain stillness in your body so that its built-in sensors cannot detect any muscle movement. With enough time and practice, your brain, or more accurately, your unconscious brain, mistakenly believes that you have fallen asleep. Then it will gradually shut down both your motor and sensory nerves, inhibiting your sympathetic nerves while stimulating your parasympathetic nerves. That ultimately leads your body into a completely relaxed state of sleep. At that point, if you continue to maintain your stillness, your unconscious brain will mistakenly believe that you have entered an even more extreme dormant state. Then it will activate the hibernation genes that have been dormant for millions of years. That process further lowers vital signs such as respiration, body temperature, heart rate, and metabolic rate to extremely low levels, even approaching a state of shock or death. With this in mind, you will understand that the legend of Buddha, who continually meditated under a Bodhi tree for 7 days and 7 nights before achieving enlightenment and entering nirvana, is not beyond the realm of possibility. You will also understand the miraculous rescue of 12 members of a youth soccer team and their coach in a cave in Thailand in 2018. After being trapped by floodwaters, they reduced their energy consumption by meditating, and were successfully rescued after more than 2 weeks of being stranded in dire conditions. Moreover, if one of the prerequisites for future interstellar migration is requiring applicants to learn meditation, it should not come as a surprise. Thus, we can redefine the biological nature of meditation as keeping the mind awake while allowing the body to fall asleep, or even enter a hibernation-like state.